So we are talking about the general motion of a rigid body. So in a rigid body, so we take O to be a fixed point in space. Okay, so we are taking O to be a fixed point and P be a point, be a fixed point in the rigid body, and G is the centroid of the body. So OP I'm taking as R vector and OG I'm taking as R1 vector. So what will be GP? GP vector will be nothing but R minus R1 vector. So we want to find the kinetic energy. So kinetic energy will be produced due to the point particles. So the kinetic energy is produced by, as well as the kinetic energy is also produced at the centroid. So the kinetic energy at the centroid is given as half m r1 dot square. So that is the velocity at g, plus the kinetic energy at the kinetic energy due to the particles is given by half summation m r dot square. So where m is the total mass of the body and m is the mass of the particle at p. Okay, m small m is nothing but the mass of the particle at p. So we are taking this. So suppose that omega denotes the angular velocity of the rigid body. Okay, so since in a rigid body there are many particles, so the kinetic energy of each particle will be given as summation m r r square. So here r can be anything, r1, r2, r3, like that. But so this is one kinetic energy produced by the particles, as well as since there is the centroid of the body is present in the body, so the kinetic energy will be also due to the particle present at the centroid. So the kinetic energy of the particle present at the centroid is given as half m, capital M, because the total mass is concentrated at the centroid, so we have half capital M, and the distance from origin to G is taken as R1 vector, so we have R1 dot whole thing square. So that is the velocity, and the velocity R1 dot we are denoting as capital V, so the velocity, the kinetic energy at G is given by half mv v vector square, and R dot vector is given, or linear velocity, the relationship between linear velocity and angular velocity is given by omega cross r. Okay, so omega cross r whole thing square is nothing but omega dot r cross omega cross r. So we are putting this value here, so omega dot I'm taking out, so summation I'm putting inside. So this is nothing but angular momentum, so you take here angular momentum. So if I donate a1 vector, a2 unit vector, a3 are the unit vectors along the principal axis at G, and a star, b star, and c star are the corresponding principal moment of inertia, then omega is given by omega 1 a1 vector, omega 2 a2 vector, plus omega 3 a3 unit vector, and h is given by a star omega 1 a1 vector, plus b star omega 2 a2 vector, plus c star omega 3 a3 vector. So this we have already derived before. So this also, so now if we take the dot product between these two, we get nothing but a star omega 1 square, b star omega 2 square, c star omega 3 square. So we have here, so this is the kinetic energy, total kinetic energy of a general body. Okay, so this is the total kinetic energy. So we can see that the kinetic energy is divided into two parts. One is due to the translation motion and one is due to the rotation motion. So this is the kinetic energy due to the translation motion, and this is the kinetic energy produced by the body due to the rotational motion. Thank you.